problem 582. So for this problem, actually, this is a graph problem. We are having n processes of performing, so it's forming a root tree structure. So for example, this is a root tree structure, and we're gonna have the PID and PPID. Yeah. So the PID is just a array. It means the ID of the ith process, and PPID is the ID of the ith process parent. Yeah. So it means this is the parent and this is the child. So let's just check on the first example. Yeah. So for the first example, inside the PID there's 1, and its parent is gonna be 3. So this is 1, its parent is 3, and similarly for this 3, because it is a 0, it means no parent. And for this 5, its parent is 3, and for this 10, its parent is 5. Yeah. So this means according to the PID and PPID, definitely we can build a graph. Yeah. Now what we're gonna do? We are giving this Q. It means if this node is Q, so for example Q equal to 5, so it means we're gonna return all the node after this 5. So definitely it's gonna be 5 and 10. So we can return the node, the value in any order. So instead of returning the node, we just need to return the value. So it's going to be a value of 5 and 10. Yeah. So yeah, that's about the question. Now let's just try to figure out a way to solve it. Yeah. So when a process is killed, all of the children processes will also be killed. Yeah. And let's also check the return. Yeah. So we're gonna return a list of IDs of the processes that will be killed. You may return the answer in any order, so that is okay. Yeah. So how can we solve it? So first of all, as I said before, let's just build a graph. It's gonna be a adjacency list. So for AB in zip, PID and its parent. So yeah. First of all, we're gonna get the parent, and then we're gonna get the child. So it means GB gonna append A. So now we have the graph. Let's just write a DFS to get the final result. Yeah. So let me just return the DFS. So what's gonna be inside the DFS? Definitely we're gonna need this kill. Yeah, because we want to kill this process and its children. We're gonna collect all its children. So we're gonna use an empty array. So here, let's just use a kill as well, and we're gonna use a result. Yeah. So let's just start writing the DFS. So for let me just use x from here. So for y in dx, so we're gonna run the DFS of the y. Because this is a directed graph, we don't need to use a weighted set or parent inside of the DFS. Because this is a directed graph, we just need to use the directed graph to solve the problem. Yeah. So from here, from the DFS here, we're gonna use this result, append the value of x. And similarly for here, inside of the DFS, we're gonna need the result. Yeah. I think that's all about it. Let me just run it to check. It didn't work. Yeah, because I return a noun. That is because I didn't give a return. Let me return the result. Now let me just run it. Now as you can see it works. Now let me just submit it to check. Yeah, as you can see it's pretty fast and it passed for all testing cases. And the time complexity is just E plus V. It is the number of edges and the number of the vertices. So according to this problem, definitely it is the number of vertices. Yeah, because the number of edges nearly equal to the number of vertices. So the time complexity is going to be O(n). N going to be length of the array. Yeah, so the length of the array is going to be 5 times 10 to the power 4. So it means, yeah, it's totally okay for this problem. Thank you for watching. See you next time.